Hey everyone, welcome back to Devs in the Shed. Hope everyone's had a really good week. I know I have. I've been on holidays a little bit, so I'm very relaxed. Paul, how are you going?
I'm also good. For the benefit of the audience, today, Matt, myself, and Navi, we're all in Melbourne, Victoria, Australia, and it has been incredibly chilly this morning. So I'm glad that I'm in a nice warm office with plenty of layers of clothes on. I had a significant amount of ice on my windows this morning. And welcome to the show, Navi. Like, how was your experience this morning on this very fresh winter's day?
Oh, I was inside with the air conditioning on, so didn't even notice until my husband went out and his car was, all ice in the on the front window. So yeah, it is chilly.
Yeah, and
Yeah.
I was just looking up the conversion, right? So it was -1, which is 30.2 Fahrenheit. So for the
Yeah.
Americans that are on the stream,
Yeah,
-1 Celsius. Yep.
It's funny you say that, right? Because like I lived overseas where it was much, much colder than it is today. As Australians, we think that that's absolutely freezing, and then that's like a big difference for us. But when I lived over in Connecticut, it was absolutely freezing. So be interesting to hear from the audience, like where you're from and whether somebody's got some pretty extreme negative temperatures today.
Yeah, and I think from our perspective, because we get up to 46 Celsius, which is 115 Fahrenheit, um, like this is the very bottom of like how cold we can physically put up with. But yeah,
Yeah.
you're right, Paul. We shouldn't whinge too much, but it is freezing for us, considering the weather change that we have in Melbourne.
Yeah.
So Navi, we have you on the show today, back again. Very happy to have you on. Outside of discussing the weather, just before we go into the new announcements, I guess, do you want to give everyone a bit of a teaser as to why you've joined in today, what you've got to present?
Yes, sure. So I'm working at Amazon as a technical lead and really interested in development of our trainers, actually authorizing them to go and instruct the customers. So that's why I have to be in the game as well. So I have to be on top of everything what's going around with AWS services. And Lambda is really my favorite. So I thought, why not go back to the basics plus introduce you to the new features of Lambda, some tips and tricks on how I'm using different features to make my life easy, and you can do that too. So that's why I'm here.
Excellent. I think a lot of people in the audience. Oh, hey, Robbie as well. You're in with Paul today, are you?
Yeah, so Robbie and I are actually at a customer site today, and I was talking to Robbie about Navi's talk and going through Lambda, and Robbie, being like a specialist in the serverless space, was just super keen to come and be part of the conversation today, and so I invited him along. So
I just want to learn from Navi today.
Oh.
And I like the visitor badge. Paul's done a good job giving you a visitor badge for the show. But I mean, we should have maybe shipped one to Navi too.
Well, he's got it on the side. I didn't drop into the room, so.
Yep, cool. Well, what I'm going to do is, before we actually get into everything Lambda, which I'm really excited for today, I'm just going to share my screen very quickly. There were a couple of things in AWS space that were worth sharing with everyone. Let me get the first one up. Here we go. So we have a new AI use case explorer. So this is a business-focused tool, but I did think that it was a pretty neat portal. I've got it open in the background. So this is what the use case explorer looks like. It's driven by business outcomes or business function. So if I go like image, it's just going to do a freeform search, and it's going to pull up the things that are relevant to effectively AI machine learning components that will help with image recognition in some respect. If I was to name like let's go factory or put something in like that, I should get like a bunch of different use cases again. It looks like some of these are the same.
Sounds good.
Yep. So digital twin, yeah. Let's go chatbot. Let's see what comes up with chatbot. Yeah, here we go. So chatbots and virtual assistants. I'm kind of searching for the technology, but you can actually pick like the industry that you're in. You could go, I'm in gaming, and I am on the marketing side, and I am looking to mitigate risk. And so it's going to show you different patterns. Of course, it's early days, so a lot of these patterns are fairly light on, but like over the next couple of weeks to months, I'd say, every industry and every business function and every business outcome should be filled in here. And people will be able to look at like what would be needed to deliver on that AI use case, who in the business and in the technology arenas would be needed to deliver on it. So a fairly handy tool. I might just go to computers and electronics. Let's click into one to see a little more about it. So computers and electronics.
Yep. Matt, because every customer that I talk to, well, not just every customer, every developer, every talk, every session that you go to that's around technology and modernization in the future is about like what to do with your data and machine learning. And it's hard because many customers don't really know what's out there, what's possible, even how to think in the future what might be out there for you to think about. Having a tool that can have these like a whole bunch of suggestions in a central place just to type it in just starts and can get you on the hook really, really quickly.
Yeah, no, and looking at it, I love the fact that the one that I chose at random led me to AI for DevOps Guru. So this is something that we actually had on the show last week as well. So I'm sure like business owners are going to use this tool, explore use cases, and that means that there's going to be innovations for those businesses, but people with AWS skills as well will be helping to deliver some of these newer, slightly more fun initiatives than your traditional stuff. Like this is helping to teach businesses, I guess, where to go to find out what they need for using their data in unique and creative ways that will help them deliver better business value. I feel that sounds quite salesy, but everyone gets the picture. The other side of the equation, which I thought was quite nice, is AWS Lambda, and it's kind of like thematical to today with Navi being on the show. But AWS Lambda's announced support for attribute-based access control. So Paul or Navi or Robbie, anyone want to kind of speak to this one in particular? I haven't looked at it myself, but I thought it's a pretty cool feature.
I'm reading at the same time as you are, Matt.
Yep, same here.
So like,
it's only dropped yesterday, isn't it?
Yeah.
Cool. So I mean,
yeah.
Okay,
no,
so it's been
Yep.
Yeah, so ABAC, attribute-based access control, was already there for a few other services. So it's like an IAM where you go by what is the job role or job function of someone and then apply the role policies according to that. So similarly, now the Lambda service, and I haven't used it myself here, but this is what it looks like, is going to have a Lambda service roles can also be created in that way using the attributes. So just an authorization strategy, but it'll be based on some attributes, not a policy already designed.
Cool.
Okay. No, it sounds fairly cool. So what I might do is I will take my screen off, and I guess Navi, you've kind of covered at a very high level in terms of a couple of cool things that you want to show off today with Lambda. I know we've got a bit of a list. I'm really excited about the Lambda at the Edge stuff. But I guess what's the first piece of Lambda that you'd like to share with the group? Like what's the first thing in Lambda that you find as a really cool tip or trick?
Okay, so there are many, many different features, right? So what I was planning to do is a little bit demo of all those different features and just maybe remembering like if you're still using those features or not, and what are some of the other new features which you can incorporate while using Lambda service. So that's my intention, going through a few use cases, just like the API gateway demos, so different use cases based on the features available.
Nice, excellent. That sounds really good, and I think the group will appreciate it. Whilst Navi's preparing for her first one, I guess, are there any tips or tricks that you've learned through Lambda in the chat? Anyone watching the show that's got something really cool that they've seen in the last couple of weeks of Lambda and thought, hey, this is gonna really help me with X or Y use case?
I think that one of the things that comes up quite often around Lambda is, yes, it's great to deploy your apps and build APIs into Lambda, but how often Lambda is doing jobs in the background for you, whether that's like, processing like some event that's come in, doing some like cron jobs or something through the day that might be like picking up and moving some files around or something like that. And one of the use cases just yesterday was this one customer was centralizing a whole bunch of logs and then pushing them off to a log aggregator, but they wanted some padding on top of the events that they were sending through, and they were just using Lambda to be able to do that. Gives them the ability to scale up as much as they need to do. And at night when it's not running, they don't need to worry about it. So, effectively there's a lot of processing and work that Lambda is doing behind the scenes that's not evident to you, even if you're like in the application space. So a lot of back office jobs are being processed and handled by Lambda. Not to say that a lot of customers aren't using for the front end, like tons of them are, but it's just a very different mindset around where you can use Lambda and how it can be super beneficial for you.
And I was surprised, and I know it's always been there, but data analytics, I come from a web app background, and working with a couple of customers lately on data analytics, it's crazy to see the amount of use of Lambda that they've got to kind of like bring different business processes together, alter the data in some form, feed it back into the data lake, connect to some of their on-premise systems and this and that. Like I've seen Lambda very heavy in the mix there, and it was interesting kind of like exploring that with them.
Yep.
Navi, I'm going to put your screen up if that's okay.
Sure. So yes, log analysis, backend cleaning, there's so much where Lambda can come handy, and you're not paying for when it's idle.
Yep.
Serverless. Okay, great. So here I'm in the Lambda service right now in the Sydney, and I've got only 10 functions here because this is like my demo account. So I'll just start with a very simple function first of all, just to explain to the very beginners, if there are any still not using it. So I've got this demo function here. It's written in Python. So as we know, there could be many runtimes. Yeah, Lambda service supports, plus you can bring your own code as well, even if it is in COBOL. But what it is this Lambda function here, it's a simple one. It just starts with a Lambda handler. There's an event which we can pass along. So if it is event-driven architectures you're using, there's some other service producing some events, they can be passed along to Lambda, and the handler will start implementing the business logic. In this case, it's just hello from Lambda. And what this context here means is, what are the things, what is it in the context of while Lambda is running? Is it producing any CloudWatch logs? Where do you want them to go? In which log group? Is there any storage? It is saving some data. Where do you want that to go? So different things while the environment is running and the business logic is going on. It's all in the form of context we can print. So it depends on how big our code or small our code is. This one has no information about what kind of logs you want, what if there are errors, what kind of retries you want Lambda to do. So just a simple function here. And if I test it, Lambda service gives me a console where I can actually do the testing, or I can do testing for Lambda locally as well. It is available in your IDE. If you're using Cloud9 on some other IDE, you can do the test there as well locally. So just a simple test here. I'm checking if it's working fine. And it gives me the execution results. Other simple basic features are it's per second billing. So you can see on the right hand side here, 1.09 millisecond it took, and the build duration is only 2 milliseconds. So per millisecond billing. Memory size we can configure, and based on the memory size and the timeout, which is in the configuration section, I'll go back to my Lambda function here. The servers behind the scenes, or that VM or a firecracker virtual machine which is provided to you to run the Lambda, is based on this memory and the timeout you have configured. So these are just the simple dials where you want your business logic needs a lot of memory. You can go up to 10 gigabytes. And if you need a lot of time for the business logic to be processed, so timeout, it can be maximum is 15 minutes. Ephemeral storage is by default provided 512 MB in this case here. So it's just a simple Lambda. But now you want to use other features which it provides. So let's go through some of them.
So Navi, just to interrupt very, very quickly, For anybody that's not familiar with ephemeral storage, what is that? What might you use that for?
Okay, so now we know Lambda is serverless, one of the core serverless services, right? So when Lambda is actually running that business logic on one of the VMs somewhere far, far away, customer doesn't have access to that VM. During this business logic, maybe Lambda needs to store some files temporarily, because the business logic could be, take two numbers, add them up, take those numbers again, now multiply them, then add the multiplication, add the sum. So all those things which is happening, if the Lambda function needs some temporary storage to store that data, it can use that ephemeral storage. But remember, those environments could be just temporary. So not necessarily the next function will, when it run, it might not get the same environment. So if you have to save something for persistent storage, use S3, even EFS, Elastic File System support is also available via the Lambda service.
Just on that, the ephemeral storage has been upped by about 10 gigabytes.
Yes.
We're going to cover that.
Yes, yes,
Sorry.
but that is, yes, there is a cost and you can change that. Yeah, so by default, as I said, that's 512 MB. But yes, so recently in the reInvent, they announced it could go to 10 gigabytes if required, if customer configures it. Okay, so let's start with some basic ones first, and then we'll go into more details. So here I have got a Lambda. When everyone started using it, it usually was for synchronous use case. So every time there is an API gateway request, Lambda would go to the job and come back and reply, say, yes, done. So that's a synchronous request, sorry. So that means the front end is waiting for the Lambda to finish its business logic, or Lambda to go and update something. In my case here, this Lambda function is running synchronously. What it does, whenever there's a request, it takes the information, run to a DynamoDB table. So this is a Python script, and it's just put that item, add it to the DynamoDB table, and return to the front end and provide a response. So synchronously, that means the front end is waiting, and this could be fine for many custom applications. So let's have a look at this, how it does it here. I've got Postman handy, which is a tool which I'll be using to send the information to synchronously invoke Lambda. So just a simple put information, and I'm going to add some data here. I'll just make it raw, and I have copying and pasting what data I want. So I'm sending the request in the backend. Lambda will pick up the data, put it in the DynamoDB table, come back with a response. This is how most people still use Lambda synchronously. But see here, we are waiting for Lambda for the response. The front end is waiting. And that might be okay for some custom applications, but usually it's a good idea if we can set up Lambda asynchronously, where the front end doesn't have to worry about the response. It has given the tasks to Lambda, and Lambda will go and run that task, maybe in batches, maybe in its own time. So that is asynchronous use case. And let's have a look at one of those examples for that.
So Navi, you've written that function in Python. Like, what's your favorite language? Do you have a reason why? And also, what are you seeing most of the customers that you deal with in training? What are they requesting when it comes to language support in Lambda?
Okay, so usually Node.js, because of the Java popularity for the front end business logics usually, and for the back end, we are looking at like .NET, C#, right? So those kind of demands are out there. But my functions are, because they're very basic, and I love basic Python. So most of them you'll see in Node.js or Python only, easy to understand and easy to demonstrate what the code is saying.
Oh, you've got some Python fans here.
That's great. Yes. So this is the example, just a synchronous example. So let's go to the asynchronous one as well.
And I was going to say as well, I did see that you had Postman up as well. That's a really cool tool that people can install locally on their machines. I used to do just a curl command to test different API endpoints that I had. But Postman allows you to put in the metadata really, really easily, and then you can save queries and stuff like that and then replace the URLs quite quickly. So just a shout out to Postman as a really awesome tool to be able to test endpoints.
Yes. Okay, so here's my CloudWatch, and I'm looking at a few log groups. So every time Lambda is running, well, because we don't have access to the machine where it's running, it's really good that we are provided with the logs so that we can troubleshoot if required. And usually when there is a log group, which is a new log group which gets created after Lambda function runs, the retention period is set to never expire. And we can have 9 years, 10 years, or never expire retention period, right? But when I'm running it, I just want to save some cost as well for the storage. So I want something to look at the new log groups and change the retention period to 2 weeks. So I'm using my Lambda function to do that. But this Lambda function, which changes the retention period to 2 weeks, is running asynchronously. It doesn't matter when the other Lambdas are running or the new log groups are created by container services or other services. This Lambda is just looking at the events, and if it finds an event where a new log group is created, it simply goes and changes the retention period. So that means the front-end service is not waiting for it to come back and say, I've completed the task. So in this case here, as you can see, it says retention has been set to 2 weeks for one of the Lambda functions. And it does it for each new log group when it gets created. So if I look at this Lambda function, I've kept the name simple, so we know what it is for CloudWatch log groups, and it's looking at the event bridge events to do its job. But what it also requires is permissions. So we have to give the right permissions to say, okay, what kind of role? So there are 2 different kinds of permissions for Lambda. One is execution permissions and one is invocation permissions. So this one is execution role, where it can execute different things. It can create its own log stream. It has the power to change the retention policy for the other log groups as well.
Navi, just on that, maybe do you want to quickly open that in a separate tab, that other Lambda function that was writing to DynamoDB, and that would demonstrate, what's required. Sure. Yeah, so because all of that falls back to the concept of like least privileges, right? So you deploy a Lambda function, it has privilege to do nothing, effectively nothing, right? Process data in its own like memory space. But by default, it also comes with, if you create one of the roles, the ability to push the logs to CloudWatch, right?
That is, it requires that basic execution role, definitely. So you can't create a Lambda function without at least that basic execution role, which has to push it to the CloudWatch. But then if you wanted to update the DynamoDB, like what I did in my earlier case, it needs special permissions to do that, put items, or maybe just get items. So it is good to have all the IAM roles with granular permissions, as granular as possible, so that there's no chance of making mistakes. So I'll show you that execution role, and this one is invocation role. So which service can invoke this Lambda? That's the other side of things. So in here, the principle here is this service called events.amazonaws.com, which is our event bridge service. So if there is an event which is happening, that can invoke the Lambda. And not any Lambda or every Lambda. We can go granular to say only this function called for CW log groups. Condition. So an source on should be for log groups. So the rule is set up in Event Bridge to only invoke this particular Lambda. So yes, you're right. We can go as granular. So that is like any other service, not just Lambda, DynamoDB, RDS, whatever we are using or our users or roles are using, we have to make sure we provide the right information. Yes, if you go into IAM, there's a lot of things. So I can show one of the granular ones here. So going to a role. As you know, IAM, there are AWS managed roles, custom managed policies, or permissions which are given to, I'll just show you the log groups one. Sorry. Oh, that is the role I already showed you. Yes, for my Lambda functions, I've got like a Lambda Almighty role for the demo purpose. So that's why I'm not going into showing the policy.
Some of my demo roles have permission to do almost anything in my account. Uh,
Uh,
it's that idea of like just make it work, and then peel your way back to making sure that it's like fit.
yes,
Whereas I think
yes,
the best practice to do is have it as least as possible and slowly increment the amount of access you're given to ensure that effectively like least permissions is given to your function there to perform as low amount of damage as possible and effectively reducing the blast radius of something going wrong in that specific environment.
yes, that's correct. But because I do a lot of demos, I've got that Lambda Almighty role. Okay, so
The job function, I guess. If you're working in a company that requires DevOps, you probably wouldn't want to do that.
definitely in production, different ideas.
Yeah.
So, so we looked at synchronous, asynchronous, but there is another event called pull event model with Lambda. So I've got a DynamoDB table here, where there is a stream. I've enabled DynamoDB stream on this table. Anytime any action is happening on that stream, I have a Lambda created which will poll that stream and come back and say, okay, I've found these two items. I'm going to do this particular business logic with those items, maybe send a welcome email or stuff like that. So in here, I'm just going to create some items in my DynamoDB table.
Effectively like a much more modern way of doing a trigger, right? Like I've had plenty of places in the past where I've said, once something enters the database, I want something else to happen. Usually a trigger typically will perform actions within the database, but I've also seen triggers, being performed on items outside of the database as well. But this is a much more event-driven approach to.
Yes, and directly from another service. So we don't even need Event Bridge in this here. Directly from DynamoDB streams, we can set up the DynamoDB streams as triggers. Plus, with a lot of configuration. So we don't want, the batch size could be up to 100 items at once. We can set up a batch window. We can set up on failure what to do. So if Lambda function by chance could not process those items, should it send it to the dead letter queue, or should it retry a few times with those items? So this is the pull event model. Polls the events.
Yeah, and batch means like for each event coming through, you can send one at a time, which will result in one Lambda execution. If you had a function that, let's just say, took, I don't know, for argument's sake, took 3 seconds to spin up and then 1 second for each process, if you put that in a batch, and let's put the batch sizes, let's just say 5, you've got the 3 seconds to spin up. Each process happens itself. So your total time would be, 5 times 1 second plus 3 seconds, 8 seconds. Whereas if you were to have a batch size of 1, the total time would be 3 seconds plus 1 times 5, which is 15 seconds. So you'd be paying for 7 seconds more than you need. So, there's some additional like savings that can be done by using batch, as well as additional performance can be had. But it does introduce some complexities, because then, if one item fails in the middle of the batch, how do you handle that and so forth?
Okay, so there are solutions for those as well. So in the batch, it can try half the batch again. It can reject the whole batch. So there are, I think recently this new feature came up where the Lambda, when it's pulling, it can break the batch into 2 and try them separately, and then break it again and then try them. And if one of the side fails, so out of 100, 25 fails, it'll then remove those 25 and put them in dead letter queue. So there are things happening on that side as well, new features coming to improve that. So this one is, I'm looking at a CloudWatch log now, where the DynamoDB stream, it took that item, and it can be, we can set it up differently to say, okay, do we want keys only the key attribute which are modified, or the all new image and the old images, like what does it want to pick up from the stream and then process it. So this is what's happening here. New and old, both images, it's picking up, and it can be done for Kinesis, SQS, DynamoDB stream. So any kind of real-time events we want it to handle.
This is a good architecture to do like a CQRS command query responsibility segregation kind of pattern. where you can have your application putting in all that information into the DynamoDB in one schema, and then have that processed and put into a query mechanism so that your queries can come up a little bit more denormalized and have your performance up there as well. So yeah, that's what I've seen a lot of our customers do in that sense.
Mm-hmm. Okay, another very popular Lambda feature is Lambda in a VPC. And sometimes people think, okay, yeah, we are now running the Lambda service within our VPC. It doesn't work like that, but it is just Lambda service is still running in its own VPC, but there is an elastic network interface created within our VPC, customer's VPC, so that it runs privately. For the services, I want to go to S3 and upload a file to S3 using my Lambda function, but I do not want to go to S3 using Internet Gateway. What I've done is connected my Lambda function to my VPC, where I can create elastic network interfaces in all the subnets if I want, but in this case I've just connected in the default VPC with one subnet, and this subnet has no NAT gateway, no internet gateway ability. There is a security group I can apply for the security group rules. So here I've just used the default security group. Going to S3, it now does not go through the internet gateway. So this is simple code, and again Python, and very simple for demo purposes. So the resource is S3. There's an object. The bucket is secure via VPC, and that's where I want my file to be uploaded, but using private IP or private connection. So there's nothing in this S3 bucket right now. And let me do the test.
So the difference between that is when you're running your Lambda function inside of VPC, it means your Lambda function is not accessible outside of your VPC. And then, so for example, if you were running that Lambda function in a private VPC and that private VPC didn't have a NAT gateway because you wanted to restrict access to anything getting out to the internet, like again, maybe to reduce blast radius. So let's say you had that, your private VPC was hosting your database, and you have no internet access to the database apart from your application layer that's pushed through from an ALB for argument's sake, right? So no requirement for anything in your VPC to get to the internet, but you've got a Lambda function that needs to write to S3. To write to S3, it needs to exit through the NAT gateway. Now, it doesn't traverse the public internet, but it exits via the NAT gateway. Once you enter the VPC endpoint, the VPC endpoint allows you to effectively use AWS's complete backbone from your private VPC directly into S3 to put that file.
Yes, so S3 or SQS, there are so many other services which use interface endpoints. We can use them privately via just this way, putting our Lambda connected to the VPC. Another one I want to show before, the container one. So here I have a application running in a container, and it's sitting in my ECR, Elastic Container Registry. And now Lambda.
Code 15 was just asking some questions about that, and Matt said that in the comments as well. So this is a common ask, like, can we use a container to retain our existing tooling patterns to deploy our Lambda functions?
Yes, and plus the size of the containers, so that is like the Lambda timeout, Lambda storage might have some restrictions, but now with the container support, we can have up to 10 gigabytes of container image. So Lambda in a container, I've got this repo where my Lambda image, the container image sitting, this application is sitting there, and what I can do is just tell my Lambda to use the image, and here we would not be able to see the code because it's deployed as a container image. So it's telling me where exactly it is. If I want to deploy a new image, I can do that as well. Go to a different repo and choose the latest image from there. I can even create my code pipeline to do all that automatically as well. So in the container app, that's the only difference. Otherwise, everything else is still the similar. We can use tags, VPC, monitoring tools, destinations, permissions, everything exactly still same. But when we change the container app, like this one here, it takes a while to update the code.
So Navi, why are customers using containers? You mentioned the specific storage. Why might someone have a very large Lambda function? What might be some of the reasons?
Okay, so one, as you said, it's like their current tooling, what they are currently used to use. So no need to change. If they've already put all their microservices in containers and using maybe on Kubernetes as well as Elastic Container Service, and now they want to make use of Lambda service, and these containers, they have to, again, the timeout does matter. So they don't want to use Fargate, which is another serverless service for containers. They can go there, Fargate, which can run 24/7 if required. But Lambda is multiple concurrencies as well. So we want event-based architecture.
Yep. And I think that when you're not deploying by containers, the maximum code size is like 100 meg or something?
512. Now it's gone up again, but before then you had the option to do 10 gigabytes.
Yeah, so it's like you needed to, you package your code, you deploy that artifact to S3, Lambda pulls in that code, and that's how it executes.
And one of the things that I've seen most customers use the image support mechanism for Lambda is to be able to run machine learning algorithms. They can just package a model into a container image, and then they can inference out of that, which is something that some customers are using Lambda for nowadays.
So I guess some of that would mean, rather than packaging that into a custom runtime and customizing the Lambda runtime, which you can have to support different languages, you take a pre-existing container and lay your application on top of that. So a little bit easier to configure.
Yeah. Another misconception with containers is that, some might think that you can just run a container on a Lambda, which is not necessarily the case. So the container image support is basically around packaging your infra and your code into Lambda, and then have the same mechanism of calling an event into Lambda and executing that environment. Not to say that you can run a container that is in ECS and port it into Lambda. That's not the purpose of the image support. Just wanted to call that out. You don't want to go back to your boss and say, you can run containers in Lambda, but it's just a matter of packaging.
I was going to say, for some people in the chat as well, have a look at the Firecracker links that I posted. It's a little bit of a misconception that we containerize Lambdas. So if you don't deliver your application in a container style manner, package it up with Docker or whatever, effectively it runs within the Firecracker platform, which is a series of micro VMs, and there's like a guest OS layer that is then used for Lambda code that you might have that's been zipped up and sitting on S3 or whatever, right? So the standard pattern for Lambda is actually to deploy on micro VMs, unless you choose the container option. And that's where you get some performance differences as well, yeah.
Yeah, I've been to one of the sessions at one of the summit events where they talked about Firecracker, and I would say, definitely for me, it was so over my head, but it was very, very intricate, details around the implementation of Firecracker virtual machine, and that virtual machine starts up in hundredths of a second or something like that. I don't exactly remember the numbers, but incredibly fast to spin up, incredibly well controlled, and forms the backbone of why we're able to get that such fast starting up mechanism of what we see with Lambda.
Yeah, and a micro VM is kind of like a cut down virtual machine, right? And cut down operating system that's been used. It's basically the host kernel and then packages and then a virtual machine that sits on top that's quite lightweight. And then that virtual machine can run containers if you wanted to, or it can basically just package up and execute the code that you've got. But the reason why we went down that route was operating this at scale, it was a very fine-grained way to control security, is have every Lambda sit within a micro VM, essentially.
Mm-hmm. Okay, so based on all the storage, right, we always want to make sure we provide the agility, but also what the developers want, the flexibility. So there's another feature here of Lambda called layers. So this Lambda here, it needs a few libraries, and this request library is not a standard library which we provide as part of the Python libraries for Lambda. But I need that to run my code. So what I can do, if I'm testing it here, it comes up and says unable to import module, no module named request. Now I could have zipped it up with my code, but I need this module for other Lambda functions as well, which I'm running in my account. So what I can do is provide it as a zipped file in form of layers. So I'm adding a layer which I have kept common out of this function. It's residing in the Lambda Layers section. I can choose some layers provided by AWS, or this one is my custom layer. It's my request modules which I've zipped up, and I can always change version on it as well. So these are separate to my code. I'm not going to go put that in my code, just using it here as a common library, adding it to the function, and now when it run it, it won't complain. So this allows you to share code among other Lambda functions as well, not just this Lambda, because it's part as a layer sitting somewhere separately. So yep, it didn't have any problem this time. So you can create a private layer, or you can actually share it with other AWS accounts as well. So that's just on the left-hand side under the layers section, additional resources.
A good example of the layer is in one of our public workshops where you build this little theme park. As part of this theme park, you have an image, and that image, like it crops out the front end, puts you on a green screen, and then does some image transformation on the green screen. And it used the OpenCV library in Python. So rather than you as somebody that's writing the code having to worry about managing and maintaining the version of OpenCV, you can package that up into a layer and deploy it, and then have your dependency not tied to your code implementation, but tied to the layer that's being rolled out. And that can be beneficial if you have a number of different teams that are using the same library. You can have that centrally managed, so you can make sure that library is, packaged up or compiled, and built specifically for your environment or your use case, and then controlled across the board. So you can say, hey, everybody inside my organization, you should be using this layer, or we're going to remove access to the other layer, and make sure that people are, staying current with their specific dependencies, rather than packaging their dependencies themselves inside their own functions and reusing that all over the place.
Yes, exactly. Okay, next one is a developer favorite, I guess. Environment variables. How do we provide? Again, similar to the layers, right? But this time it's about the environment variables, which should be separate, shouldn't be within the code. So this is again a Python function. So sorry, I didn't have any other examples today for some reason. So I'm going to talk to my database in this case here. So what we can do here, keep the variables in the code, but provide the values in environment variable sections, and not just in plain text. We can provide the values using the KMS key management system keys as well. So here my host is in plain text, user admin, but the password is encrypted. So I've used the helper for encryption in transit, and I can also use the KMS key to encrypt it at rest as well. But this one, I'm just using the default AWS Lambda key. So that's the environment variables out of the code. And let's have a look at the code here. When we were talking about the Lambda handler, event, and context, and trying to keep that environment where the Lambda is running, we can reuse the environment. There's no guarantee that AWS will keep running that Firecracker VM for you to run your Lambda functions. But most probably, if it is still warm, and when you're running your function, you can reuse that environment. And that's why I'm just looking at here the environment. We are importing the encrypted environment variables and then decrypting as well as part of this function. So just to show you the test. So when I do a test on this and type in the event name, okay. So this is the magic what's happening. I didn't click anything. I don't know what it's doing. So just bear with me. Okay, happy for me to do the test now. So in the function log, so there's nothing in that response here. In the function log, it goes and says, yes, I'm connected to your database and I've decrypted your password as well. It needs access again to the KMS to do the decryption as well. But if I have to change the password, I don't have to worry about updating my code. I only have to update my environment variables. There's actually another very good service which you can incorporate with Lambda called app config. So you don't even have to come and change your environment variables in the Lambda console. You just do it through the app config, which is in one of the features of Systems Manager.
So Logan asked the question, so you can inject credentials via environment variables, like from a vault of some kind. So yes, if that's exactly what you can do. But you could also pull those in at runtime from like parameter store or from secrets manager for a specific secret as well. And also Navi alluded to the code that sits outside of the execution loop. So the code like such as DB host or encrypted, that will be executed and stay persistent. So that variable encrypted or decrypted will stay persistent across invocations of that Lambda function. If once that, how do I rephrase it?
Because they are outside the handler.
Correct.
So it will be only done once, and then the business logic. And if there are invocations coming again and again, some event is happening, it will only run this part, not try to encrypt every time, because it has encrypted that. And I actually will show you this with another example, simple example called warm start. So, and this is going back a few times as well. Now we have provision concurrency, and we are going to talk about it. But this is when the customers were trying to keep the environment running, that virtual machine running Firecracker, so that it keeps warm, and it doesn't have to, every time there's an invocation, doesn't have to go and look for a new VM, even though it takes a few milliseconds to start up. The customers wanted something which is already running. So in this case, what they were doing with the code is setting up what needs to be done just once, like that environment, the secret password for the database to be decrypted just once. So in this case, I have an outer which is equal to 0. But then once it starts running the handler function, and lucky for me, this is a Node.js example. Once it starts running that handler function, the outer is not going to change.
Mm-hmm.
It will be just the same. So outer +1, because it's not going to put it back to the 0. It is going to just run this business logic again and again. So let's have a look at and testing this to see what happens. So I'm testing again, and now I'm going to show you what's happened here. So inner stays at 1 because it goes down to 0, then it's 1, 0, 1, 0, 1, but that outer is not going back to 0 anymore.
Yep. And that abides by the concurrency of that Lambda function. So if there are 2 invocations of that Lambda function at the exact same time, the outer will start again at 0, and you'll have 2 of those Lambdas being warmed.
Yes. So this was earlier, as I said. Now we have better options. So what's now is the concurrency provided. The concurrency settings for this region by default is 1,000 invocations, right? But I don't want those 1,000 invocations to be used by all these functions, because some of them are my development functions. I want my version function to use a number of concurrency settings I want to set up for this function. me have a look. Yep. So I want to reserve the concurrencies. Out of that 1,000, I've got 50 reserved concurrency for this function. So that means 950 can be other functions, but this is an important function. So 50 concurrencies are reserved. But this is also an upper limit. So if this invocation for this function happened 51 in the same second, it's going to say, even though there are other concurrencies available, it will not work. It'll only take the 50 of them. And in this reserved concurrency, on top of that, I can also have provision concurrency. I want 10 environments to be up and ready, even if there is no invocation. So I'll have to pay extra for this, but these 10 environments are kept ready by AWS for me in case there is this function, someone invokes it. Okay, so that means there won't be a cold start. It will always be a warm start with the provision concurrency. Okay, showing you
And for
another.
that, it will burst outside of that. So if you say, I'm allowing my function to have 50 maximum instances running, but I've provisioned 10, that would mean most people, most of the time, would have instant response because the Lambda would be warm. But let's just say we had a burst event. The Lambda function wouldn't throttle. It would allow you to burst outside of that 10 warm events and start up another one. However, those customers might incur some of that cold start. So their response might be like slightly slower while the next iteration of the Lambda is warming up.
Yes, and although we are covering that gap, AWS is trying to make sure, there's a very good, whenever the invocation happens, is not much cold start. We're covering that gap, but in this way, in your production account, the customers can make sure they reserve some concurrency, they provision some environments according to their requirements. And 1,000 is just a number, which is a soft limit. So customers can always raise a support ticket, and that number can go to tens of thousands of concurrencies. For Lambda, it's really cool.
Yeah, the 1,000 is there because I know that I've made this mistake. I don't know whether Robbie has or Matt has. Probably Robbie has, right?
I've seen this happen. Yes.
Yeah, where you accidentally write a function that, your denial of service attacks yourself, where you've written a function that calls another function, and then there's been some infinite loop, and all of a sudden everything in your whole account just goes down because you're running thousands and thousands of Lambda functions all at the same time. So that the 1,000 concurrency is there to both probably because, for a long time you might not need that. And secondly, to sort of protect yourself. And like Navi said, when you need more, or when you find you're needing more, you just log a support request and that gets put through.
Concurrency is another topic for another day. You can have a whole session on Lambda and concurrency. But there's good documentation on our documentation website as well. So I'll see if I can share that with you guys.
Okay, another thing before I'm mindful of the time, this Lambda at Edge is also really becoming popular. So we know the CloudFront distribution, which is running an application on our Edge locations, providing content to customers if it's a global application with low latency. So I also have set up a website for that. So after setting the website, I want it to be globally available to everyone. So I have set up a CloudFront distribution in front of it. It gives me a distribution domain name as well, or I can just use my own custom domain as well. But what I have done is change the behavior of this the CloudFront distribution. What I've done is put a Lambda, associated a Lambda, which will run at Edge before the request from the customer will make to my backend. Or it could be run Lambda at Edge can be run at 4 different times. So when the viewer requests something, I can associate a function to do some compute or inject some headers or check some kind of authorization before it sends the information to the backend. Or I can create a similar Lambda or some different business logic for when I'm providing the response to the viewer, when I'm sending the request to origin, or in my case, when the origin is providing a response. So this function, this website, it's usually when it provides a response, it's like some security features are not built in. So this Lambda at Edge has some security stuff, which I have built into Inject at the time of providing the response. Starting from here, so just strict transport security to enforce HTTPS. So it's injecting this response header, content security policy, and cross-site scripting protection, content type options to make it no sniff. It's going to inject that. So that means on my backend, my web application, it's an old one. I don't have to make any changes. I'll just run Lambda at Edge. But this doesn't mean that my website is insecure or something. It's just like extra security we are injecting here. So in the Lambda, this particular one I've added with version number, but this Lambda for the Edge work has to be in US East. It has to be created in US East, although it will then run in all other regions as well, but we have to do it in North Virginia. So now if I go to the CloudFront distribution here, let's just run it once. Sorry. There are many ways we can check if our website is, how it is giving the content secure or not. And one of them is this particular website called observatorymozilla.org. You might have heard of. I'm just going to put my domain here and tell it to scan and tell if it is secure or not.
So one of the interesting things that you said, Navi, was that this function is deployed in US East 1 and then behind the scenes propagated to all of the other regions. So yes, that means that this Lambda function is actually run in region, in availability zones, rather than like at a point of presence. So
yes, and that we can see from the logs. So because I've just run that website in Sydney or in Melbourne right now, if I go to the logs, CloudWatch logs, see this Lambda, US East 1 for Edge work, but it is showing in my Sydney region as well. So whichever region it is running, it will create the logs there, even though the Lambda is in a created in different region. And what it's doing is, as we were looking at the code, it's just injecting some extra security headers. And that's why it's A+ here. It says, yes, you have those extra headers. So that's Lambda at Edge.
I think one of the other things that came about fairly recently, not so recent anymore, is CloudFront functions as well for your Edge activity. So yeah, yes, whenever you're doing your coding for that kind of aspect, think about both Lambda at Edge and CloudFront functions. Both of them has pros and cons for each. So it's another design decision that you'll have to make.
Yeah, Lambda at Edge lets you use all of our languages. CloudFront functions are JavaScript only.
Yeah, just because they're new, right? So slowly, yeah, there will be new features. So another one here is when in production, we are using Lambda functions and then we want to update or try some different code in the business logic, but we don't want to upset the production version. In that case, we can use this basic Lambda feature is available from long time ago. We can actually, once our code is ready, we can go actions, publish the new version as well. So when we publish the new version, there's still a problem that now we have to go to the production and change the version number to 1, 2, 3. Instead of doing that, we can also use another feature called Alias. So in the versions, I've got a few versions of this Lambda function, but I'm calling my version which is in production prod Lambda. So I've given it a name, not the version number. And I can change the alias behind the scenes, but I don't have to go and change anything in production because it'll still say prod Lambda. So in here, prod Lambda is the alias, and I can edit it to say, no, I don't want to use version 2 anymore because there's a version 3 of the function. I want to use that. So I don't have to do anything in the front end. And it's now going to use this new alias. And this again can be checked in. I've got an event which is running this particular function every 10 minutes and producing logs. So if I look in the logs, it was publishing version 2 because that is the alias. But now in the next, whenever it runs next time, it is now going to use a different version. So it's actually looks like still, yeah. So it'll just take, because this is a cron expression, so every 10 minutes it'll run, but I don't have to go and change how it is running. And I would be able even will just show you the rule where it has no mention of version. It's just the alias which is running. So in the backend, we can change the alias to point to a different version whenever it's updated.
No, this is pretty cool. I feel like we could spend like hours going through all the little hidden functions that people don't really see day to day when they use Lambda. Let's have a look at this one last, because I know Paul and Robbie, they're actually on site.
We have to go. Someone needs to go to the meeting. Did you want to finish it off?
This was this was my last example anyway.
Thanks all, Matt.
Cool.
You
guys. Yeah, you guys drop, and I'll finish with Navi, and we'll. I think we need session 2 on this. I feel, because everyone in the chat's loving it too. Oh, did we actually see it, Navi? I just saw your screen dropped.
Yes, no, I stopped sharing because that was my last example anyway. Yes.
Perfect. Yep. No, that was fantastic. I was getting excited, but I was trying to keep to the chat, because some of the things that you showed off, like I absolutely love, like most people that are using Next.js for websites these days, they'll be hosting the static content on S3, and then they're kind of using Lambda at the edge really creatively to effectively do some of the server-side functions, like dynamic resizing of images or executing different routes that are happening on the server end. So Lambda at edge is a big thing, along with CloudFront functions. I'm trying to remember what was the other one that I was getting excited about. But I feel like we could have a whole session on testing Lambda locally on your machine, as well as putting Lambda into a CI/CD pipeline, and using CDK pipelines or SAM pipelines as the feature to achieve that, and then being able to do unit testing behind the scenes before you do deployments. There's literally so much.
So many things. Yeah, exactly. And that's why I wanted to do this basic one as well, because we keep forgetting what we already have, and we are trying to incorporate all these new features and forget about the basics one, which are so useful as well. So
yeah, well, it was awesome having you on. I know that Paul and Robbie had to drop very quickly. I'm on my holidays as well, so it's been fantastic having you on and taking us through this. We are going to have you back for another Lambda or API gateway session soon, because I can see that the chat loves it. Yeah, CDK. CDK is even, that's one of my favorite things as well. So definitely dive into that. But what I'll say is I'll catch everyone next week. If I remember correctly, I think Paul's got something that he's going to show off next week to everyone, but I need to double check the calendar. We're on same time every single week, and I'm sure we'll have Navi back, in the next few weeks. So thank you very much for attending, everyone, and thanks Navi for coming in and showing us all this cool stuff. Excellent. I will end the stream now, and Navi, if you want to stay for 2 seconds, just feel free to, but I will kill the stream, and I'll catch everyone next week. Thanks, everyone. Bye.